Alrighty, good afternoon everybody. Today we're going to be studying about Lewis dot diagrams. Chemistry is governed by the interactions of the outermost electrons of one atom with the outermost electrons of another atom. These electrons found in the outermost or highest energy level of an atom in the s and p orbitals are called valence electrons. So again, valence electrons are found in your outermost energy level and include only the electrons in the s and p orbitals. Valence electrons are the number of valence electrons an atom has can be determined multiple ways. You can utilize its electron configuration. If it's known, you can utilize the electron configuration and calculate the number of s and p orbital electrons of the highest energy level. Added together, those equal the number of valence electrons. You can also utilize the periodic table. The group numbers on the periodic table can be utilized to determine the number of valence electrons for that group and therefore for all of the elements in that group. So utilizing electron configuration. If we have selenium, it has 34 electrons. Its electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p4. I'd like you to take a minute and try and identify what the highest energy level of selenium is. Once you've done that, try and calculate the number of valence electrons. Pause the video and go ahead and do this. Alrighty, so you should have correctly identified the highest energy level as 4. There are a 4s orbital and 4p orbitals available. For selenium, it has 2 4s orbitals, 4s electrons, and 2 4p electrons. So 2 electrons in the 4s and 2 in the 4p. When you add 2 and 4 together, you get 6 valence electrons. So selenium has 6 valence electrons. Let's take a look at barium. It has 56 electrons. Its electron configuration is as follows: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, and 6s2. I'd like you to take a minute and identify its highest energy level and the number of valence electrons in that energy level. If you've thought about this, you should have correctly identified that 6 is the highest energy level available in barium, and there's only a 6s orbital, and barium only has 2 electrons in there. So there are 2 electrons in barium's highest energy level, giving you 2 valence electrons. Utilizing the periodic table is a little bit different. So you'll notice this is a blank periodic table, but there's something a little bit different about this, and this is that the transition metals in this periodic table have been left blank. And the reason for that is that transition metals do not follow any major pattern associated with the valence electrons, so we're going to leave them alone and not discuss them. And the reason that they don't follow any major pattern is because a lot of the transition metals themselves can actually have a different number of valence electrons, and we'll get into that later. But for now, just know that you would never be asked to determine the number of valence electrons in a transition metal, because you can't do it without being given more information. So if we start at the left of the table, we have group 1, also known as the alkali metals. We have then group 2, the alkali earth metals. Skip on over the transition metals, we go to group 3, group 4, group 5, group 6, and then we hit group 7, which are the halogens, followed by group 8, which are our noble gases. Now the number of valence electrons corresponds directly to these numbers. Group 1 has 1 valence electron, group 2 has 2, group 3 has 3, group 4 has 4, group 5 has 5, group 6 has 6, group 7 has 7, and group 8 has its full complement of valence electrons of 8 valence electrons. So let's take a look at barium. Barium is located in the 6th row of the periodic table in the 2nd group. And since it's located in group 2, it's going to have 2 valence electrons. Selenium over here is located in the 4th row of the 6th group. And so being in group 6, selenium has 6 valence electrons. Now, all of this information about valence electrons can be utilized and applied to a Lewis dot diagram. Lewis dot diagrams help us to do 3 things. They identify the number of valence electrons an element has. They can then identify the group number the element can be found in, excluding transition metals. And finally, they can show us the ion most likely to be formed when an element completes its octet of 8 valence electrons. So let's take a look at selenium. Selenium, we know, has 6 valence electrons. And so we start filling it in right here on the right, and then we go counterclockwise or anti-clockwise. So with 6 valence electrons, we go 1, 2, 3, 4, 5, 6 valence electrons. Now when I talk about the ion most likely to be formed, in order to reach its octet, selenium would only need to gain 2 more electrons to get to those total of 8. And so selenium, it would be a lot easier to gain 2 electrons to get to 8 than to lose 6 and drop down an energy level to get to that other 8. So selenium will gain 2 electrons to fill in right here. If selenium is gaining electrons, it becomes negatively charged, so it becomes selenium 2 minus. Let's take a look at barium. Barium only has 2 outer shell electrons or valence electrons, so we're going to fill them in there and there. Since barium, it is a lot easier to lose 2 electrons than to gain 6, so barium will actually lose electrons. Electrons are negatively charged, so when he loses electrons, barium will become barium 2+. Now we're going to practice a lot of this tomorrow in class, so I want you guys all to go out and have an enjoyable evening trick-or-treating or doing whatever you're doing. If you do go out trick-or-treating, please remember to be very safe, be aware of who you're talking to and who you're taking candy from, and just the darkness that is going to be tonight. And please, please be kind to those people who give you candy, and also be kind to any little kids you might see. Don't try and scare them. They are very sweet little kids, and Halloween is stressful enough. So be kind, be safe, and make good choices. See you guys later.